Hi guys, so after we have understood what is solid, what is liquid and what is gas, and we have understood that in a fashion it's all about force of attraction that broadly divides the categories into solid, liquid and gas. Okay? But does that mean that all the liquids have similar kind of force of attraction? No, it's just a broad classification. Okay? So first of all, we have to study a new thing today, that is interconversion between the broad three states of matter that we have studied, that is solid, liquid and gas. So this broad three states we will study in detail. How does this behave and how does the interconversion in between them really go on? Before that we need to understand what is the energy of a particle. Suppose a particle is there in a solid, suppose this is a solid particle, solid state you can say. So particles are closely packed, right? We know particles are closely packed like this, isn't it? Closely packed. The basic reason that we have understood between the reason why these particles are closely packed is that I have said you that there is high force of attraction or high intermolecular force of attraction between the particles. High intermolecular force of attraction is there and you have believed it, that's fine. But definitely if we are considering the mechanical energy of a particle, then mechanical energy consists of two energies. Okay. It consists of, first of all, potential energy, second thing is kinetic energy. Okay. In case of potential energy, this potential energy is basically defined from the force of attraction between them. Okay. Potential energy is defined from force of attraction between particles. The potential energy is basically given by the force of attraction of the particles. Okay. Next is the kinetic energy. Kinetic energy is shown by the movement of the particles. In this case the movement of the particles at this moment is very low and that is why they are closely packed. Fine. This kinetic energy of any molecule or any particle is given by a sensible parameter. Sensible parameter means something that can be sensed. Okay. So what can be sensed in case? It is temperature. So some thing that has high temperature will be having high kinetic energy. Okay. Something that has high temperature will be having high kinetic energy. So kinetic energy is directly proportional to temperature. Okay. Kinetic energy is directly proportional to temperature. Okay. So at this moment this is a solid. Okay. Now suppose let's take ice. This is a ice crystal. So some ice crystals are put into a beaker and you start heating it in a Bunsen burner. You put one thermometer over here. Okay. So definitely suppose at first the temperature is at minus 10 degrees Celsius. So as soon as you heat, this temperature is going to go up. Right, from minus 10 degrees Celsius this temperature will go up like this. So it goes up like this at 0 degrees Celsius. It stays for some time. Until what time it stays at 0 degrees Celsius? Whenever this is moving like this at 0 degree Celsius, you will see the ice is melting until the total ice over here has become water. This remains at 0 degree Celsius. What? Until total ice has become water, temperature remains constant at 0 degree Celsius. This is very important. Before that, while it was getting heated from minus 10 degree Celsius to 0 degree Celsius, what was happening here? Minus 10 to 0 degree Celsius, I was supplying heat energy. Which was basically increasing the temperature of this ice, right? So from minus 10 to 0 degree Celsius was brought about by this heat energy. Agreed? Okay. So this heat energy was getting converted to what kind of energy? It was getting converted to kinetic energy, and that is why we were seeing change in temperature. That is why we are seeing change in a parameter which is sensible. So I'll just rub this. From minus 10 degree Celsius to 0 degree Celsius, this part, heat energy was getting converted to kinetic energy, Ke. This kinetic energy is basically vibrational kinetic energy. Isn't it? These molecules were vibrating like this. Okay. As much as you are increasing the temperature, that heat energy of that was getting manifested into kinetic energy, vibrational. This was vibrating with much and much higher speed, and as that is the basically exuberance of the kinetic energy that was showing in terms of temperature. So this part, when heat energy was getting converted to kinetic energy, here vibrational kinetic energy, this part, this heat energy is called sensible heat, because you can sense this. This energy, heat energy, is called sensible heat because you can sense it, and this energy was increasing the vibrational kinetic energy. Okay? This energy was increasing the vibrational kinetic energy. After that, we are going to study about, can I rub this? Okay. About what happens as soon as it reaches 0 degree Celsius. So, when it reaches 0 degree Celsius, okay, first of all the ice reaches at 0 degree Celsius, and it remains at 0 degree Celsius. It remains at 0 degree Celsius till all of this ice converts to water. Okay. All of this ice is getting converted to water. So definitely, if you see, what is the difference between ice and water? The difference is, in ice the molecules are closely packed. In water the molecules are not so closely packed, right? It is like this. Clear? So that is the difference, nothing else. Ice and water, closely packed and not closely packed, solid and liquid, simple. Okay. At this moment, we need to understand this very important thing over here. At this moment, the heat energy is not getting converted to vibrational kinetic energy. At this moment, heat energy is getting converted, or rather I would say it is getting used, it is getting used to overcome force of attraction, that is the potential energy, overcome the force of attraction between particles. Okay. So this is to overcome the internal force of attraction between particles, something that is not visible to your eyes or you cannot sense because it is not temperature, right? You cannot sense it, it is internal. That is why this heat energy is called either hidden, because it is hidden inside the molecules, inside the matter, hidden, or latent heat. ठीक है, clear? I hope everything over here. Now let us see this one. There is a solid which gets converted to liquid. So this is a process, definitely this is a process, and this process is called fusion or melting. Okay. While the liquid converts to solid by cooling, definitely this process is called freezing. Okay. For solids, while getting converted to liquid, there is a specific temperature at which a solid gets converted to liquid. The temperature at which the solid gets converted to liquid is called fusion point or melting point. ठीक है, fusion point or melting point, the point where the solid gets converted to liquid. Next is, at this point we have learnt there is no temperature change, temperature remains constant, that is for water at 0 degree Celsius, this is 0 degree Celsius for water, the temperature remains constant till all the ice changes to liquid water, right? So at that point of time, whatever heat is supplied is called latent heat. At that one is having a term, that is latent heat of fusion. ठीक है, latent heat of fusion. Now we will be taking a case of liquid to gas. This process of conversion to liquid to gas is called boiling or vaporization. Vaporization. The opposite process is called condensation, or you can write liquefaction. ठीक है, remember, for any liquid, that is pure liquid, if the liquid is pure, pure means one component, single component means only water or only alcohol, like that kind of thing. Okay, so let's take only water. Let's take our example as water. So we know all this water boil into steam or water vapor at 100 degrees Celsius, which is 373.15 Kelvin. Okay. This is for single component. For single component, you will be having a specific temperature which is called boiling point. For a single component, you will have a specific temperature which is called boiling point, at which the liquid is going to change over to gas. Okay? Liquid is going to change over to gas. And definitely you will be also having a liquefaction point or condensation point. But this is only possible if the liquid is pure. If the liquid is not pure, then whenever liquid starts changing to gas, if the liquid is impure, I will take this side. Multi-component, I will take multi-component liquid, that is water plus alcohol, let us say. Okay. So whenever liquid here changes to gas, there are 2 points. At the first, when liquid starts changing to gas, at this point it is called bubble point. Okay. And the last point where all the liquid has changed over to gas, it is called dew point. So basically, if it is a multi-component liquid, then you will have a range of boiling points rather than a single boiling point. But up to class 10 level, normal boiling only, if you understand well, that will be much more than enough. After that, इसके लिए time है. ठीक है? Even though it's foundation, then also I am saying up to this is okay. I am just giving you the idea. In case of multi-component liquid, there will be 2 points. ठीक है? Clear? So in this case, which is our basic point of study, at this point, that is at 100 degrees Celsius, water will continue to boil at 100 degrees Celsius till all the water have not changed to vapor. During that time, the heat supplied will be definitely latent heat, and that latent heat will be called latent heat of vaporization, generally denoted by LV, and in case of latent heat of fusion already discussed, that is generally denoted by L subscript small f. ठीक है? Clear? So now we are going to understand what is sensible heat in mathematical terms. Okay? Sensible heat, some mathematics about it. So see, if this is Q, Q is the heat energy, that is sensible heat, I will write it S. Okay? That is whenever there is change in temperature, that is from liquid to liquid, solid to solid, that kind of temperature changes. It is mass of the substance into a quantity which is called specific heat. Okay? Into a quantity which is called specific heat. This is called specific heat into delta T, which is change in temperature. Okay? So this is the sensible. If you want to calculate sensible heat, suppose you want to calculate sensible heat of water, there will be a specific heat of water listed down in a table. Along with that, you multiply the mass of the water you are calculating and what is the temperature change. Suppose it is given the temperature of water has risen from 30 degrees Celsius to 40 degrees Celsius. So, temperature changes 40 minus 30, 10 degrees Celsius. Okay. With that, you put the Cp value. Cp value of water is 4.187 joule, this is joule, this unit is energy unit is joule per kg per degree Kelvin or Celsius. ठीक है, Kelvin के लिए degree नहीं चाहिए. ठीक है. So this is the unit. So nowadays we write it like this: 4.187 joule kg minus 1 Kelvin minus 1. ठीक है, in exponential terms. So this is how you calculate specific heat. Clear? Now we will be showing you how you calculate sensible heat is done. Now we will be showing you how you calculate Before I go into the latent part, remember this is specific heat. So if somebody asks you to define what is specific, why this term is important? If you say the specific heat is independent of whatever mass you take, but Q, the sensible heat, is dependent on mass, but the specific heat is not dependent on mass, which is important. So please write it down. Specific heat is not dependent on mass, but Qs, that is sensible heat, is dependent on mass. Now we will be doing latent heat. As we know, latent heat does not change any temperatures. So this part will not be there definitely. So this one I will mention as QL will be is equal to M into L. Now what is this L? This L is specific latent heat. Specific latent heat. Clear? This L is specific latent heat. Again, for different substances, this latent heat will be there given in your question, and you have to put this to get the value. What is the unit of latent heat? Let's just find it out. L should be QL by M, right? Q means energy, heat energy. Its unit is joule. Mass unit is kg. So joule per kg. This is the unit of latent heat. Clear? So these are the two heats basically required for our conversion that we have seen. One is sensible heat, another is latent heat. Clear, guys? Okay. Now we will be doing a simple chart of interconversion. We will be doing a very simple chart of interconversion. Okay, it's a very simple one. Solid, liquid and gas. Okay, so there can be solid to liquid, liquid to solid, solid to gas, gas to solid, then liquid to gas, gas to liquid. So all this we need to do now. Okay. So first of all, solid to liquid, everybody knows fusion or melting. Fusion, or you can write melting. Okay. Solid to liquid. And now liquid to solid, what it should be? Freezing, correct? Liquid to solid, freezing. Liquid to gas, boiling or vaporization, whatever you want to write. Boiling or vaporization. I hope you know the spelling. Gas to liquid, it should be condensation or liquefaction. So I'll write condensation this time. There are certain compounds or substances rather which changes directly from solid state to gaseous state without going into liquid state. Examples are camphor. Camphor is, if you are a Bengali, camphor is called kopur. It is used in your rituals in our house when we give pujas and all. So you can ask your mother or father, they will be able to tell you what is camphor, better than me at least. Okay. Next is NH4Cl. It is a sublimable solid. I2 sublimes. Naphthalene, this one you know, we generally use it in bathroom, gives nice odor. So naphthalene, these are some of the examples of your sublimable solid. So what they do, they directly go from solid to gaseous state without going into liquid state. So this process is called sublimation. You can write down, sublimation is the process of conversion of solid to gaseous state without going into liquid state. Okay? That is definition part. What is gas to solid? Basically it is called deposition. Basically it is called deposition. Okay. Now I have 2-3 facts to discuss with you guys about liquefaction. Okay. 2-3 small factors I need to discuss about liquefaction. Okay. It will be important, in fact very important. From gas, if you want to go to liquid, what are the process you can apply over here? See, gas is like this, right? And liquid thoda pass. यही तो है difference. So how can you really do it? You can change to gas to liquid. Definitely something is coming into your mind. Number one is टेम्परेचर को घटाओ, ठीक है ना, यू रिड्यूस द टेम्परेचर, ठीक है, एग्रीड. व्हाई नॉट नंबर 2, प्रेशर, you can increase the pressure also to bring the molecules together, right? If you increase the pressure, the molecules will come together. So both this process can be applied to convert gas to liquid. Now the question again comes, why take the help of pressure when I can do it by temperature? Well, there is a point called critical points. This is very important. Critical points, ठीक है. There is a temperature which we know as Tc, which is critical temperature. Please write down. Critical temperature. This is for every other gas, ठीक है. For every gas there is a temperature that is called critical temperature. Write down please. If you have a gas, suppose you have a gas where temperature is more than critical temperature, ठीक है ना, a gas in which you have temperature at this moment more than critical temperature, like air, ठीक है, at this moment the air's temperature is more than critical temperature of air. So if it is the case, then you can't liquefy a gas only by reducing temperature. So you have to in this case apply both the methods. You have to in this case apply both the methods. There is another term which is called PC, definitely critical pressure. Critical pressure is the, you can write down, critical pressure is the pressure at which gas can be liquefied at critical temperature. So if the gas is at critical temperature, you need to have critical pressure to liquefy the gas. Okay? Clear? Okay. Now coming to some important topics on boiling. Just the opposite of liquefaction. Okay. So liquid getting boiled to gas. So liquid का तो force of attraction अलग होता है, gas का अलग होता है. So all the liquids should have been having the same boiling point, same amount of heat would have been required to change it to gas. But it doesn't happen so. Why does this not? Doesn't happen so? Because force of attraction, remember, force of attraction of different liquids are different. Force of attraction is different for different liquids. So definitely the boiling points and the heat required will be different, isn't it? It should be different. Okay. If the attraction is less, boiling point would be less. If the attraction is more, boiling point would be more. Okay, simple. In water, suppose in water the attraction between the molecules of water is very high. That is why water boils at a very high temperature, that is 100 degrees Celsius, and thank God for that. Otherwise you wouldn't have got water in the earth if you would have boiled in say 2 degrees Celsius. कहीं पे मिलता ही नहीं पानी, है ना? So attraction कम होने से आपका boiling point कम हो जाएगा. So this is very important. If somebody asks you, giving you a hint that this is the boiling point of this substance A, this is the boiling point of this substance B, and they will ask you that what is the reason for this difference in boiling point, then you need to list down. There will be MCQ exam, so it will be listed down like this: 1, 2, 3, 4. There will be 4 options. One of the options that will be there, the force of attraction of in between the molecules for different liquids are different. That is why the boiling point was set, not different, right? Different force of attraction, different boiling point. Same force of attraction, same boiling point. Okay? Clear? So I think all the points have been discussed. Now the last part is evaporation. For evaporation, I would directly go into the difference between evaporation and boiling. Okay. Here I will write evaporation, here we will write boiling. Okay. So you have to find the difference between them. So first of all, boiling takes place at a particular temperature. For pure liquids I am taking. Okay. Takes place at a particular temperature. It can take place, this evaporation thing, they can take place at any temperature. Right? Proof, your wet clothes, if you put on your roof, whether it's a winter season or whether it's a summer season, it is going to dry out. The reason is evaporation. It doesn't depend on temperature whether it will be occurring or not occurring. Temperature will guide whether it will be occurring fast or slow. So we will come to that. But evaporation occurs at all temperatures. Next very important thing is there, when you boil something, boil a liquid, that is a wholesome phenomena. Boiling doesn't happen like that, it will be happening only from the surface. The total liquid gets boiled, okay, it gets boiled, total liquid. So this is a very important point. It is not a surface phenomena. This type of phenomena is called bulk phenomena, when the total liquid is getting boiled. So boiling is a bulk phenomena. This is an important word. Whereas evaporation happens only from the surface of the liquid, so it is a surface phenomena. ठीक है? When a surface evaporates, suppose when I took my bath today, when I came out, definitely some droplets of water was there in my body, so it evaporated and I was feeling quite cool, which I am not feeling right now, definitely without the fan running even. So that moment of time, some evaporation has occurred, and when the evaporation has occurred, there was some cooling taking place. I am going to explain you the phenomena. Okay, there was some cooling taking place inside my body, because this liquid has gone to the vapor state, taking some kinetic energy out of my body. लिक्विड वेपर स्टेट में चला गया, मतलब बहुत दौड़ रहा है उधर जाके, इसका मतलब कहीं ना कहीं से तो उसको एक्स्ट्रा काइनेटिक एनर्जी लेना था, वो मेरे बॉडी से ले लिया, ठीक है ना। तो बॉडी से जब काइनेटिक एनर्जी उठा लिया, मतलब टेम्परेचर कम हो गया बॉडी का, है ना। सो दैट इज वाई माई बॉडी वॉज फीलिंग कूल. सो इन एवापोरेशन इट कॉजेज कूलिंग. It doesn't cause any cooling. ठीक है, it doesn't cause any cooling. ठीक है, you need to give some external source of heat and that will go out. So clear guys, this is about difference in evaporation and boiling. Now I am going to explain to you how does evaporation cause cooling. Simple mathematical explanation, won't take much time. So this is liquid. The surface particles of the liquid that you can see over here, this changes to vapor state. Okay, so it is taken away by the vapor. So this surface liquids changes to vapor. When this surface liquid changes to vapor, definitely its kinetic energy has increased. It is going here and there, ठीक है ना. So kinetic energy of surface liquid changing to vapor is derived from the bulk liquid. This is number one. Number two is, so average kinetic energy of bulk liquid decreases, hence temperature decreases. If kinetic energy decreases, temperature will decrease. You write complete, decreases. Number four, so liquid becomes cool. ठीक है. So this is how evaporation causes cooling. ठीक है. What are the factors that affect evaporation? Just think. See, what does evaporation need first of all? It needs kinetic energy. काइनेटिक एनर्जी बढ़ाने के लिए आपको क्या देना पड़ता है? टेम्परेचर, हीट, है ना. सो इफ द टेम्परेचर ऑफ द सराउंडिंग्स इज हाई, definitely it will gain more and more kinetic energy from the surroundings also, and evaporation rate will be quicker. So you can write down number one is temperature of the surroundings. ठीक है ना, temperature of the surroundings. Number one is temperature of the surroundings. If the temperature of the surroundings is high, evaporation rate will be quicker. Number 2, we know evaporation is a surface phenomena. Evaporation is a surface phenomena. So larger the surface, larger will be evaporation. Likh do. Larger the surface, larger will be evaporation. Clear? Number 3, evaporation is going from liquid state to vapor state. Already if in the surroundings there is lot of liquid, that is there is lot of humidity, then the evaporation rate will be down. That is why in rainy season your wet clothes doesn't dry much, right? You understand that? Okay. So you write humidity in air decreases evaporation, because if there is lot of humidity means lot of water vapor already in the surroundings, then these water vapors will not be allowed to go into the surroundings. Already lot of water vapor is there. Okay? Clear? Humidity decreases evaporation. Number 4, wind. If there is lot of wind blowing, ठीक है, बहुत हवा चल रहा है, तो evaporation rate will be increased. जितना हवा चलेगा उतना molecules को लेके चला जाएगा. Write down. With wind, the evaporation increases. ठीक है ना? With wind, the evaporation rate increases. Last one, nature of liquid. Now, normally people skip this part. This is very important. Nature of liquid. You please write it down. Liquids having higher intermolecular force of attraction. Liquids having higher intermolecular force of attraction will have less evaporation. Higher intermolecular force of attraction means it will not be easy for the liquids to go out in the vapor state. ठीक है ना? Liquids having higher intermolecular force of attraction will be having lesser evaporation rate. ठीक है? Okay guys, discuss another very important part over here, that is vapor pressure. If there is a liquid like this, okay, there is a liquid over here as you can see, and normally suppose this is a boiling liquid, okay, so there is some vapor of this liquid at this top portion which is in equilibrium with this liquid, okay, which is in equilibrium. This is a little bit deep concept, just try to understand. Vapor pressure is this film of vapor produced by this from this liquid only, a film of vapor of this liquid produced at the surface of the liquid will exert some pressure, right? Will exert some pressure like this towards atmosphere. करेगा कि नहीं करेगा? करेगा ना? गैस vapor pressure create करेगा ऊपर जाने का. So if this film goes out in the atmosphere, then another film will form, and this way film by film boiling is going to go up. This is called film boiling. Okay? Film by film boiling is going to happen, and this level is going to come down. Talking boiling over here guys. Okay. So first a film of vapor is formed, and this is going to go out. If possible, if goes out, then another film is going to get formed. So this pressure, whatever this liquid is giving towards atmosphere, is called vapor pressure. So you can please write down the definition of vapor pressure first. Please write down vapor pressure of a liquid, vapor pressure of a liquid at a specific temperature, may be defined as the pressure exerted by the vapor present above the liquid, pressure exerted by the vapor present above the liquid, okay? Pressure exerted by the vapor present above the liquid in equilibrium with the liquid. ठीक है, you write down in equilibrium with the liquid is called vapor pressure of the liquid, ठीक है. So definitely this vapor pressure what you have learnt now, PV, is dependent on temperature. It is dependent on temperature. So vapor pressure will increase if temperature increases. Why? Because if the temperature increases over here, molecules is going to fight more, दौड़ा दौड़ी ज़्यादा करेगा तो प्रेशर ज़्यादा खींच देगा. ठीक है, टेम्परेचर इंक्रीज होने से वेपर प्रेशर ज़्यादा इंक्रीज होगा. वेपर प्रेशर विल ऑल्सो इंक्रीज इफ intermolecular force of attraction decreases. So if there is a liquid which doesn't have much of intermolecular force of attraction, more and more molecules will be in this film. So more molecules means more pressure, simple. So vapor pressure will increase if the intermolecular force of attraction decreases, or if it is a liquid with lesser intermolecular force of attraction, vapor pressure will decrease. Now definitely you can understand that there is a atmospheric pressure which is acting over this vapor. At this moment, let's say no boiling is taking place, but suppose the temperature is getting increased. At a certain point the temperature becomes Tb, that is the boiling point. What is this point? At this point vapor pressure becomes equal to atmospheric pressure. That is it. When vapor pressure becomes equal to atmospheric pressure, this will break through the barrier and molecules is going to go out into the vapor state. Simple hai? Okay? So that is what vapor pressure is and how does it affect or directly relate to the boiling point. Can I rub this? To discuss two other important topics before I go into the gaseous state. So we are not going to go gaseous state in this one because we are going to study it in a much more vivid way, the gas laws, much more vivid way. Gas laws, chalk. I need a solid chalk. Okay. Two important things. One is surface tension. ठीक है, surface tension. Here is a liquid. So suppose here is a liquid particle. This is going to get attracted by other particles from all the sides like this, right? All the sides. So all the force is going to get cancelled out. Clear? The bulk one. But there will be a molecule over here, say it is going to get attracted only from the lower side like this. Clear? So this will have a net perpendicular force like this towards the liquid. ठीक है, net perpendicular force towards the liquid. Please write down its definition. Force acting at right angles. ठीक है ना, force acting at right angles to the surface along unit length of the surface. ठीक है, the unit for this is force acting along unit length. So Newton मीटर -1. ठीक है, this is surface tension, very brief idea, but I think you have understood. That is what my intention is. ठीक है ना. So these are different properties of liquids that we are going to study. Later on also we are going to study lot of things. Next is we are going to study about viscosity. Viscosity, important or not? Very important. Viscosity is basically a property of a liquid. It's a property of a liquid, I would say fluids rather. It's a property of liquid and gases due to which its flow is restricted. Okay, please write down. It's a property of fluids and gases due to which its flow is restricted. You can also write like this way, it is the resistance to flow. It is the resistance to flow. Okay, it's the internal property of the liquids and gases. Units you have to write down here. Unit is kg. Okay, I also forgot basically, so I'll take this one. Okay, so this is it, kg per meter per second. This is the unit of viscosity. So what is it really? It is a property by which the flow is restricted. Like I will just give you an example. If you take oil, okay, if you take mustard oil and put it in the floor, you will see it percolates a distance. If you take water and put it on the floor, it also percolates distance, but much more distance than mustard oil, because mustard oil has higher viscosity than water. Okay, so that is why it percolates less. Okay, if you have high viscosity, flow will be less. If you have more viscosity, flow will be high. Next important thing is diffusion, which you have already studied. So diffusion was what? Diffusion was, here is the ball, you connect another ball, this is gas A, this is gas B, and you just open this, both becomes A plus B. So this is diffusion, right? There is another phenomenon which is called effusion. Okay? Which is called effusion. What is effusion? Effusion is, they call it that it is quite similar to diffusion, I agree, but it is basically, suppose this is the condition. So here is A and here there is also A, but here the concentration of A is, let's take 100, and here the concentration of A is 1. So definitely the pressure of A is more than this pressure of, let's take A dash. So from higher pressure to lower pressure, when the movement happens like this, from higher pressure to lower pressure, when the movement happens like this through a pinhole, okay, it is from higher pressure to lower pressure. Diffusion is not such, same pressure, idhar udhar, intermixing. But effusion is from higher pressure to lower pressure. This is called effusion. Okay? It will be from higher pressure to lower pressure. Okay? So this type of questions you should be able to handle. Next is, there is a liquid, and for effusion pinhole is very important. There is a liquid, put some some chalk dust or something like that inside it. You will see there is a zigzag motion of the chalk dust at first, as long as it doesn't settle. This zigzag motion is called Brownian motion. Okay? So zigzag motion of particle inside a liquid or gas is called Brownian motion. Okay? Zigzag motion of a particle inside a liquid or gas is called Brownian motion. Clear? So that is it all about states of matter. We'll cover the gas laws, that is the another state is still left to go into a little bit more detail, and I should go into it. That will be in the gas law part. So, that will be a separate video altogether. Okay, a separate worksheet on this is provided to you. Please solve them, and afterwards we will release the answers of that also. Thank you.